Okay, so yep.
Oh, I do remember.
Lesson 13 is inverse trig functions and trigonometric equations. Okay, so we're going to talk about inverse trig functions. If you take a moment and flip to the next page in your notes, you'll notice it's those three half circle things. Okay, that's not the very teachery way of me saying it. Okay, but we will talk about those half circling things. Those half circles specifically they show us where our answers can be for an inverse trig function. Okay, because not just anything can be an output there. So, if I say, find the sine of 30 degrees. What is the sine of 30 degrees? 1/2. Now, so, on the quiz test, I saw some of you made the chart, yes? Well, I think it was you, Logan. I think it was you.
I knew it would be.
Okay, so this one's pi over 4. What's this one? Pi over 6? Pi over 3. Someone flip-flopped these two, and I think it was you. So, or maybe multiple people did it, but I remember looking at someone, I was like, how did they miss this? They have the chart, and then...
I'm just not smart.
Okay, sine, cosine, those are the two columns you really need. Tangent is helpful. Let's review the chart. I'm reviewing this chart just because I know not everyone quite has it yet. Okay, the trig question on the test was a little rough. Okay, a lot rough. So, what goes right here? If the sine of 30 is 1/2, where else? Cosine of 60 is 1/2. Okay, what else do you know? Okay, cosine of 30 is square root of 3 over 2. What's that mean down here? Square root of 3 over 2 for sine of 60. My 45s are square root of 2 over 2. Okay, you know those columns, my opinion is you can get the rest. Because tangent is always sine over cosine. So if we do sine over cosine here on the bottom row, basically think about the denominators are the same. They cancel each other out. Square root of 3 divided by 1 is square root of 3. Something divided by itself is 1. This one is 1 divided by square root of 3, but we know 1 divided by square root of 3 rationalizes to be square root of 3 over 3, yes? Okay. So, anyways, I just, the more we can make of that chart, the better, right? Yeah. The more we can practice. I know we need it. But it doesn't help that part of the time we would have been practicing that chart, we were not face-to-face last year. So, I know that does not help. The beginning of calculus, there's always a lot of, okay, we've really got to work on that. But I feel like this year, we've really, really got to work on it because we didn't get to practice as much last year as we should have. At least not together. So, okay. So, if the sine of 30 degrees is 1/2, how can we find sine x equals 1/2? What? Well, officially we don't think left, right, middle because it's not a log. Yeah. The whole idea of the inverse trig function, if we're trying to find sine of some angle equals 1/2, then the inverse says we switch our input and output. So that the sine inverse of 1/2 equals x. So if you're trying to find sine inverse of some angle, of some number equals an angle, sine inverse of 1/2 equals x. And what's that going to be? That's going to be the 30 degrees or pi over 6. Okay, so name of the game today is the inverse trig functions. I think last year's book used alternate ways, didn't they? I think when I introduced them.
Yeah.
I tend to do sine inverse, so sine with the -1.
I remember saying
I introduced arc sine, yes?
That sounds
Okay. The calc book likes to use arc sine. Okay. And then, I don't know that I ever see where they actually just write out inverse sine like that, but,
Maybe
it's good to know, right?
Those are all the same thing.
Yeah. Yep. All the same thing. Three different ways to say the same thing. Okay. The following are the graphs of the three inverse trig functions. Memorize. On an upcoming test, you will have to draw these graphs. Well, you've got some work to do between now and then. On an upcoming graph or test, you will have to draw these graphs. Now, so sine inverse. Think about it, okay? Sine inverse. First of all, think about the actual sine graph. How high and low does an actual sine graph goes? And it goes from -1 to +1. So notice that means that is my domain on sine inverse. If it's my range on sine, it's my domain on sine inverse, because domain and range are flipping. Now, the angles are from -π/2 to +π/2. So, when we do this, all of our answers for sine inverse must lie between -π/2 and +π/2. Notice those 2 points are the endpoints of what we can look at. If you, next page. What is this chart right here showing? That all of my sine inverse answers end up on the right side of the circle, yes. Keep in mind though, this -π/2 is not 3π/2. It is 3π/2, but yet we cannot express it as 3π/2. Okay? So we're expressing from -π/2 to +π/2. Okay. I don't know why these graphs are in the order they're in. I tend to think about cosine next, which is this far one. Notice my x values are -1 to +1, just like the normal range on a normal cosine graph. The difference here is my angles, are 0 to pi. And so if you flip and look at the back side, all of our answers must be between 0 and pi. Where is 0 to pi? That is the top half, right? And that is the one time you use all the angles just as is. Okay? On sine, you have to be careful. This isn't 11 pi/6 right here. This is -π/6. Things like that. You have to watch out. And lastly, tangent. Okay, I don't know. We reviewed tangent a little bit this year. No, have we reviewed tangent yet? I'm not sure we've reviewed tangent yet. Okay? Tangent is basically a graph like this, except vertical. Remember, it's the vertical graphs that they kind of look like the cubic graph. It's the vertical ones. Excuse me. Notice -π/2 to pi/2 here. The negative of 1 and 1, I don't know. I don't even normally put the -1 and 1 on the graph. It's more about, to me, having the asymptotes of -π/2 and +π/2. Okay? If you flip back to the other page, basically tangent inverse has the same output as sine inverse. The only difference is that it's not defined at π/2 and -π/2. So it does not include those endpoints. So this right here, I'm just going to put as your reminder, see the graphs on the next page. Okay. Shall we practice? First example is a little bit easier example. Evaluate sine inverse of radical 2 over 2. So what is this asking? At what angle does sine equal radical 2 over 2? 45? Pi over 4 if you prefer? Okay. So sine inverse of radical 2 over 2, when does sine equal radical 2 over 2? And you can either say pi over 4 or 45 degrees. Okay. So if it's a positive sine inverse question, you're just looking in quadrant 1. So did some of you guys use the chart behind me then? Or maybe the chart in your head, whichever, but honestly, I think you had your chart perfectly fine, except you flip-flopped to both pi over 3 and pi over 6. I think. You'll get it. Okay, let's try the next one. Evaluate cosine inverse of negative radical 3 over 2. So first of all, it'd probably be helpful to, my brain tends to ignore the negative for a second. When does cosine equal radical 3 over 2? 30 degrees or pi over 6, yes? Now, is that my answer? No, because that's the first quadrant answer. Okay? Visualize with me. Where are cosine answers allowed to be? The top of the circle, yes? So my cosine answers, this is your visual, can be anywhere from 0 over to pi or 180, whichever you prefer. Now, you guys already identified that right here, $30, right? 30 degrees or pi over 6. That is the answer if we're in quadrant 1. In quadrant 1, everything is positive though, right? All. So everybody's positive. So we don't want the answer over in quadrant 1. We want the equivalent answer in quadrant 2. So this one is 30 degrees or pi over 6 up from the x-axis. That means I need the equivalent reference angle over here, meaning if this one's 30 degrees up over here, we need the one that is 30 degrees up over there. What is 30 degrees up over there? I think I heard both answers out there. Okay. If you want to go degrees, it's 150, yes? Because 180 minus 30 is 150. However, you also know that trig functions tend to go more with radians. And so, if this is pi, what is pi over 6 away from that going to be? 5 pi over 6, because this is 6 pi over 6, right? 6 pi over 6, take away a pi over 6, makes this 5 pi over 6. Now, I guess I never talked about, is this the right answer? All students, what do you know about this angle, or this quadrant? Yeah, sine's positive, but everybody else is negative, right? So when we're talking cosine, positive cosine answers are in quadrant 1, negative cosine answers are over here. So, your answer, depending on your mood, is 150 degrees or 5 pi over 6. Is that a good enough explanation? Excuse me. Well, let's solve some trig equations then. Solving trig equations is just like finding inverse trig functions, only we now will be given different intervals to stay between, so we must use our unit circle. So, solve secant x equals -2, and it says from 0 to 360. That means you're going to want to give me all answers you can that exist between 0 and 360. So, thoughts on that equation, secant x equals -2. Okay. Secant is 1 over cosine. Or a different direction that I might go with this. Well, okay. So secant and cosine are reciprocals, yes? So if I change this secant to read cosine, what's that do to this -2 over here? What? Makes it -1/2. So what I would change this equation to read is cosine x equals -1/2. Now, I can't necessarily tell you when secant equals 2 off the top of my head, even though it should be easy because it is the reciprocal of 1/2, and thus the reciprocal of cosine. I can't necessarily tell you that. However, can you talk to me about where cosine equals 1/2? Yeah, we can talk about that pretty easily, can't we?
Yeah.
And that's what we want to do. So, at this point, there's not really solving other than you're just going to have to give me answers. I'm a picture type of person, so I'm going to draw a picture. What are we going to be looking for here? Cosine of what equals 1/2? It was cosine of 60, yes? Or if you prefer, pi over 3. So that's where my brain's got to think, is where does cosine of 60 equal 1/2 type thing? Now, what quadrants do I need to consider here? Dale says the left two. Why is he only considering the left two? Yeah. All students take calculus. We need to look for quadrants where cosine is negative. In quadrant 1, everybody's positive. In quadrant 4, cosine's positive. So that means we're looking in quadrants 2 and 3. And we want these 60-degree angles. So that means I want the angle over here that is 60 degrees above the x-axis, because remember the x, that's our reference axis, right? And we want what else? The angle that is 60 below. You got those? And here's the nice part. Gotta love it. They gave me the range as 0 to 360. So what kind of answers are they expecting? Degrees. Take the easy route out. What are my answers? 120 and 240? I agree. 120 degrees, 240 degrees. Because up here in quadrant 2, it's 60 degrees above 180. So 180 minus 60 is 120. Down here in quadrant 3, it's 60 degrees past 180. So 180 plus 60 degrees is 240. So answers of 120 degrees and 240 degrees. That was not an inverse problem.
So the password was only for the inverse.
Correct. Correct. So yes, if you see inverse, we have to worry about staying in our correct quadrants. If we're solving an equation, like what we were just doing here, you have to consider all 4 quadrants. Realizing if it's a positive, there's probably 2 positive answers. If it's a negative, there's probably 2 negative answers. Okay. Are you ready for the backside? Okay. Thoughts on how to solve sine squared x equals 1. I realize our answers we're going to be looking for between 0 and 2 pi.
It's very both sides.
Realize when we look at this, it says sine squared x. This is the same as thinking sine x quantity squared. If you have a squared on a side, how do we undo a squared? We take the square root. If you take the square root of the left, take the square root of the right. What's the square root of sine squared x? Sine x. What's the square root of 1? Plus or minus 1. Because in an equation setting, you have to check both the positive and negative roots. So we really have 2 equations to solve here. We want to know, when does sine x equal positive 1? And when does sine x equal negative 1? Okay, I don't know how much we've reviewed this year. Yep, you got to think about the axes here. Think about there being a point on each axis, right? And that point is 1 out from the center. So if I go 1 right, 0 up or down, that is the ordered pair. 1, 0. If I go 1 up, but I did not go left or right, that is the ordered pair. 0, 1. 1 left. It's negative 1, 0. And then 1 down. 0, negative 1. What is the order in an ordered pair on the unit circle? Cosine, sine. So, with that in mind, when does sine equal 1? Up here at the top, which, yep, that's a good question. Do you remember what that is? Pi over 2. So on the first one, x equals pi over 2. When does sine x equal negative 1? Down here at the bottom, which is 3 pi over 2. So we have solutions of pi over 2 and 3 pi over 2. Notice we used, radicals, radians, because our answer range was given in radians. Please stop me if there's something I need to review better on the unit circle, okay? I'm trying to review as I go. Because honestly, otherwise I wouldn't have even drawn that. I would have just said, give me the answers and went on. But okay, next one. Tan squared x equals 3. So we're going to square root both sides. Square root of tangent squared is tangent x. Square root of 3? Officially, I need to say plus or minus the square root of 3?
Excuse me.
So, officially, we have two equations to solve, right? When does tangent x equal the positive square root of 3? And when does tangent x equal the negative square root of 3? Okay. Thoughts?
Again,
Okay. Heard pi over 3, and I heard we're going to have 4 answers. Because what? Tangent x equals square root of 3 is going to be the two positive tangent quadrants. Tan x equals negative square root of 3 is going to be the two negative quadrants. So you're going to have an answer for every quadrant, yes? Now, Mallory, you said pi over 3. Since they gave us degrees, instead of talking pi over 3, I'm going to use 60. Okay? So, I've got one of my positive answers, 60. Do you guys need the visual? I'm going to draw it whether you want it or not. So there's my 60 degrees. What other quadrant do I need for positive square root of 3? All students take calculus. So if we were just looking for positive answers, which is officially what I'm doing right now, I need down here, yes? So I need to look and see what is 60 degrees below the x-axis, which is going to be 240, because it's 60 added on to 180. There's my positive answers. Now, when does tangent equal negative square root of 3? Well, when's that going to happen? That's going to happen in these other two quadrants. So now, same thing, using that reference angle of 60 degrees. So up here in quadrant 2, what is that? 120, because it's 180 and you're taking away 60. What about down here in quadrant 4? What? 300? Because it's 360, right? We don't want to go from 0 here. That doesn't really help me. So 360 minus 60 is 300. Notice, as Daryl predicted, I ended up with 4 answers. And yes, I could have just gone around and listed all 4 of them, but it's also important to understand which ones are the positives, which ones are the negatives. Okay. Got it? Example 6 then. Cosine squared x plus 2 sine x minus 2 equals 0 for once around the unit circle from 0 to 360. You guys remember anything about doing these in pre-calc? Do you remember enough to get us going, though? We are going to use an identity because here's what I'm going to say. So this equation, I have a cosine squared and a regular sine. If I'm going to have one function that's squared and one function that's not, it's going to be easiest on me if I have all the same function. So in other words, all sines or all cosines. Now, there's an easy identity. It's the one identity that I can 99.9% sure you guys could all give to me that we could use here. What?
Is cosine squared x plus 1 equals sine x. Sine squared x.
Okay, so what is the Pythagorean identity that involves sine and cosine?
So sine squared plus cosine squared.
Yeah. So we're going to use, and I'm just writing it out here so you remember. Okay. The identity I'm going to use, is the idea that sine squared theta plus cosine squared theta equals 1. So, with that being said, what can I replace cosine squared x with? Cosine squared theta, if I solve this, would be what? 1 minus sine squared. So we're going to replace cosine squared x with 1 minus sine squared x. I'm still going to have plus 2 sine x minus 2 equals 0. Clean up your like terms here. Negative sine squared x plus 2 sine x minus 1 equals 0. I don't know if all math teachers are like this or if it's just me, but because I know I'm getting ready to factor, I don't like that negative being on the front term. So I'd rather have a positive sine squared x. So multiply everybody by 1 or move everybody to the other side. But I'm going to change this to make it sine squared x. It's now minus 2 sine x plus 1 equals 0. The equation I have written, sine squared x minus 2 sine x plus 1 equals 0, needs to be factored. Here's the algebra equivalence that you guys should be able to factor. Does this look familiar? X squared minus 2x plus 1. X squared breaks into x and x. What multiplies to be 1 and adds to be negative 2. Negative 1, negative 1. You can factor that, right? Algebra 1 was a long time ago, but you've used that a lot since then. So, we're going to do the same thing here. 2 parentheses. Sine squared x breaks into sine x times sine x. It's still what multiplies to be 1 and adds to be negative 2. It's still minus 1, minus 1. So basically, I just took my x's and replaced them with sine x's. What do you do when you have both 2 parts multiplying to equal 0? Set each part equal to 0? Exactly. So sine x minus 1 equals 0, or sine x minus 1 equals 0. Really, you don't have to write it twice. I would be fine if you just wrote it once there. So, solve. I'm going to have to bring this over here. Now we're looking at sine x equals 1. Go up to the top example on this page if you don't want to have to redraw anything. When does sine x equals 1? 90 degrees. Previously we said pi over 2, but they want degree answers here. Is that the only time? For positive 1, yes. Right. Now if it'd be plus or minus, there'd be 2 answers. It just kind of depends. You did that stuff last year. That might have been right around the time e-learning was beginning. So I'm not sure. I don't know. Anything that happened during e-learning is up in the air as to how successful it was. I mean, I know I taught it, but I couldn't see your faces to get the grasp of understanding. Okay, one last one. 2 sine squared x plus 3, or equals 3 plus 3 cosine x. Okay, what are your thoughts while I get my computer screen back? What are you saying, Mallory? Well, actually, I think you're one of the, there's a couple of different things I need to hear here. Here. Okay, I agree. We do want to make this equation equal to 0. That is one of the steps that will need to happen. So if we go ahead and do that, 2 sine squared x, subtract over the 3 cosine x, subtract over 3 equals to 0. Except there's not a 2 in there. It sounded like you said 1 minus 2 cosine squared x. And it's just 1 minus cosine squared x.
I was thinking of the multiply everything I do.
Oh, okay. Okay, I'll do that in a moment. Okay, you were going ahead. Got it. Okay, so I'm going to say, I'll do that next step. You can do it right now if you want. 2 times, okay, sine squared, Pythagorean identity from above. If you solve for sine squared, it's 1 minus cosine squared x. Still, minus 3 cosine x minus 3 equals 0. And then, yes, now I'm ready to distribute, which is what Nathan was trying to do earlier that confused me. So 2 minus 2 cosine squared x minus 3 cosine x minus 3 equals 0. What'd you say? Clean up. So negative 2 cosine squared x minus 3 cosine x minus 1. If I'm going to factor again, I'd prefer a positive squared term. So I'm going to multiply everybody by negative. 2 cosine squared x plus 3 cosine x plus 1 equals 0. Well, regardless, that makes life nicer because it's positives. Okay. Do you need the non-trig version of this to visualize? 2x squared plus 3x plus 1. To me, this is a really easy guess and check. But what's the alternative if you don't like my guess and check? Product of AC. There's only, the reason I say, look at this with me real quick. I know you guys don't like my guess and check, but just use your brains, look at me. Or look at this. 2x squared, what has to be that if we're factoring? The only way that could go is 2x and x, correct? In a typical factoring. Look at your last number. 1. What's the only way that could go? 1 and 1. Multiplies to be positive, adds to be positive. That's like a real super easy guess and check because the only thing we really have to check is does my middle term match up? Well, first is 2x squared. Outsides, 2x. Insides, 1x. What's 2x and 1x? 3x. And then last is 1. If that didn't make you happy, then product of AC all the way, right? I'm just saying that this particular problem was a super easy one to do that way. Okay? I get it. They're not always that easy. Okay, so the only difference is now instead of x's, I'm going to write cosine x. So 2 cosine x plus 1 times cosine x plus 1. And set each part equal to 0. subtract 1, divide by 2. And just subtract 1 on the other one. So we need to know, when does cosine x equal negative 1/2, and when does cosine equal negative 1. Okay, all students take calculus. Cosine equals negative 1/2. What quadrants do I have to be in? The left two. Okay. When does cosine equal positive 1/2? Pi over 3, yes? So in quadrant 1, cosine equals 1/2 pi over 3. So we need, for this particular problem, pi over 3 up and pi over 3 down. What are we going to be adding and subtracting pi over 3 to? Pi. What is pi with the denominator of 3? 3 pi over 3, yes? 1 pi is the same thing as 3 pi over 3. So, you got some answers for me then? If you go pi over 3 up, 3 pi over 3 minus 1 pi over 3 is going to be 2 pi over 3. If you go 3 pi over 3 forward, 3 pi over 3 plus 1 pi over 3 is going to be 4 pi over 3. And when does cosine equal negative 1? So when is the x quadrant, or excuse me, x coordinate negative 1? And that is pi. So this particular equation, we ended up with 3 answers. Okay. This pre-calc is coming back to you, right?
Yeah.
I'm hoping.
Yeah, honestly, yeah.
Okay.